So we're on a bit of downtime now between batches. So I've got a couple of days to be able to do a few modifications to our freeze dryer. So as we go to the back, where the working parts are, it's a little bit more messy. But one modification I've been really keen to do is this discharge line that comes off the compressor gets red hot. And obviously these things use a hell of a lot of power over a long period of time. So if we can harness this for the heating in the home, potentially, maybe some hot water, at least I'll be able to get back some of that energy. So it's just how we're going to do it. So this is something I was working on earlier. It's a bit difficult to do a video because I was fiddling around with the stuff for so long. Anyway, this is the end result. We've got a bit of 15mm copper, just standard copper for water. And then we've got a bit of refrigeration 1/4 inch, which will come off the discharge. Same as what's on there at the moment. So I'll braze that to the discharge, and then these will flow water around the system via a pump. And I'll be very interested to see what sort of efficiency we get in terms of heat transfer. It's quite a simple setup, just a tube and a tube. They're quite common in the refrigeration industry, but they're sometimes ribbed rather than just a smooth bit of tube for better heat transfer. But we're trying to keep the costs down. We don't want to spend too much. It's not like we're going to be getting a huge amount of money back on this investment, but it is going to help with the efficiency of the freeze dryer as well, because water is going to cool it far better than an air cooled condenser, which we'll still have on it. Also, with the temperature warming up, it's gonna, where we're using a higher pressure refrigerant in a system that is not really meant for it, we're using R410 in a R404 compressor, just really because we can get a lower temperature with R410, but it is a higher pressure. So what we don't want is the condenser getting too hot in warmer weather, and now we're coming into summer in the UK. Even though we don't get very hot summers normally, the days do get warm, and we will be putting that compressor under a considerable strain if it gets too warm. So to liquid cool is definitely the way to go in these circumstances, or at least to do a bit of a pre-cool like we're doing. Not necessarily it may not condense in this, it may only stay, it may just go into it may just pre-cool it and then liquefy it in the compressor, in the condenser. Right. Protect that plastic. I normally would solder this obviously separate, but if I take these out I won't be able to push the pipe back in due to the fact this is going to be soldered to this bit of pipe. And I wanted to keep the connections pretty simple because I'm running plastic pipe back to the hot water tank. So after managing to find a suitable place to clip it,
I'm ready to braze it onto the compressor.
Got our bottle of nitrogen ready, connected up.
I've managed to braze it into the discharge, and then it goes through
To the condenser. Time to braze. Next bit is fitting the pump. So I've got a Grundfos heating circulation pump with some adapters, and let's get these connected. So I'm just going to put a plug on the end of the watt cable at the moment, just so we can just run some tests. And we have power. What I've done is I've just got a bucket of water here at the moment. So with the pipes running into it, all I'm going to do is run a really crude test just to see how warm this water gets. There's about 10 litres in there. It will just be interesting to see how warm that gets and how long it takes to get warm. Obviously there's a lot of inefficiency, none of the pipes are insulated. If it gets pretty hot, then I'm really happy that we're going to probably be able to extract quite a lot of heat from the system. But it's a bit of a cheap and crude setup at the moment, but just for testing purposes. So the pump's running about 5 watts. I've got on the slowest speed, and I think that'll be a sensible flow rate for it. We may need a bit more power when we're running it to the main house. Obviously it's got to pump it up many more meters, but that flow rate, I'm not sure what flow rate that is, but probably a couple of litres a minute. So from the
So I've got two temperature probes now on the system, on the discharge line going in and coming out of the heat exchange. So it says it's about 59 going in, but that's probably more like 70. The probes aren't very accurate unless they're really clamped on tight, so I would say it's probably more like 70. The 22 is probably more realistic for the outlet, so that's quite a good heat transfer considering it's only a homemade heat exchanger. The water, considering it's going to lose heat through all this copper pipe and everything on its way to this bucket, and then lose heat in the bucket or around the bucket as well. It is lukewarm, and it is up to about 26 degrees, which ain't bad considering the compressor's using about 450 watts. We've got, and this is going to be wasted heat otherwise. I think this warrants spending a bit more investment on insulating the pipe work and sending it to the main tank in the house, because if this machine runs about 24 hours a day, so I think we'll get the tank pretty warm by that time if we can reduce the losses. And it also helps with the efficiency of the unit, because this condenser is barely having to deal with any heat load. We only have, and considering we're getting that much heat out of it with only one tray, this machine's running easy at the moment. This will run a lot hotter on the discharge when the machine's under a lot more strain. Normally the condenser temperatures when it's under heavy load will be around about -36. Obviously this is coming up to the end of drying now for this one tray in here, so it's not under so much strain. The plan will be to connect it to this tank, which is our heat store for the house. And normally this is used for the fireplace, but obviously that's only used in the winter, and to be honest, recently it hasn't been used very much. So this tank at the moment is pretty redundant, but perfectly set up, ready to go, as it's got the heat exchanger, so it basically takes over from the combi boiler when the temperature's rised on it, and it will help the combi boiler out. So absolutely perfect to work, already set up and perfectly ready to work with the freeze dryer heat exchangers.